on what's new in 3D. This webinar will discuss how 3D GIS plays into the digital twin strategy. We wanted to show you how the combination of reality capture, beam integration, and point cloud with other 3D and 2D data can simulate single facilities and entire cities, and how they can provide automation of future predictions. For those of you that haven't attended one of our webinars, we are recording the session and we will email you the recording along with the slides after the webinar. If you have any questions about the content we are presenting, please use the QA panel. Be sure to choose to ask all panelists. Type your question in the box and click send. We will take your questions at the end of the webinar, but feel free to type your question in at any time. If we couldn't take your question during the webinar, we will follow up with you afterwards. I'm Sepide Seper, a technical solution specialist based out of the Calgary office, and I'm joined by my colleague Hannah. I'll let Hannah introduce herself.
Good morning, everyone. Welcome. I'm Hannah Cole. I'm a technical solutions specialist here in the Prairies region with Esri Canada, and I'm very excited to join my two colleagues today to present to you. So thank you and enjoy.
Thank you, Hannah. Today, we are honored to have Lee Brampton as a guest speaker from Esri Inc. Lee, please let us know about yourself.
Hi, thank you. Yeah, I'm happy to join. My name is Lee Brinton, and I am based out of our Redlands headquarters in California. I hail from Halifax, Nova Scotia, and my role at Esri is the 3D practice lead for professional services.
Thank you for joining us, Lee.
Anytime.
This webinar will explore the value that BEAM, point cloud, CAD, and integrated mesh provide to the digital twin workflows. We will highlight the best practices working with these contents. We will learn about the improvement in 3D in ArcGIS Pro and ArcGIS Online. And we wrapped up this webinar by gaining a deeper understanding of the road ahead for 3D in ArcGIS. Lee, it's a pleasure to have you with us. Can you initiate this conversation and tell us why Esri is investing so much in 3D solution and digital twins? We wanted to know what value 3D brings to this digital world.
Sure, absolutely. So from reality capture to design and engineering data, we're seeing an explosion of new types and methods of collecting 3D data. LiDAR sensors can be mounted to backpacks, trucks, trains, drones, airplanes, and satellites. We're seeing high-resolution global-scale mesh created from aerial and satellite imagery, underground information from millions of boreholes, and even indoor positioning systems to help support the next generation of 911. With the availability of new data types, and data is driving the demand for new GIS experiences. So from people like you, in past years at our user conference, a lot of us were surprised to see an absolutely packed audience at our AR and VR presentations in our demo theaters. Throughout my career in the last 10 to 15 years, I've seen the expectations go from consumer markets like gaming communities end up infiltrating the professional software product industry. Now, as we look closer at our user expectations for new types of GIS experiences, we see a greater demand on your mobile device, visualizing real-time data, running deep and smart analytics, and ultimately something that's visually compelling. We've noticed that 3D has become a unifying common experience between all of those. Now, users are not just adopting 3D because it's new, they're adopting it because it has intrinsic value. It can provide a more accurate representation of the real world. It can allow you to communicate with non-technical stakeholders, and it'll even allow you to see features that don't exist or that can't be seen, like features underground. Now, it's for all those reasons I mentioned so far. ArcGIS is a comprehensive 3D GIS. It allows you to work with various 3D formats and specifications, share your data inside 3D clients such as web and even native applications, perform 3D analytics and simulations, and even combine reality capture data with your real-time content.
Thank you, Lee. With what you explained, I think it's time to answer this question of how 3D GIS plays into the digital twin strategy. How about starting with the definition of the digital twin? The term digital twin has been around for a decade, and it applies to any industry. Digital twins are a virtual representation of the real world that incorporates physical objects or processes, relationship between objects and behaviors. GIS creates digital twins of the natural and built environment and uniquely integrate many different digital models. GIS is a creator of content and digital twin itself at various types. The reason why GIS is connected to digital twins is that it's all about location, and location is what ties everything and everybody. Digital twin brings together many platforms in the form of a system of system approach. One of the problems that digital twins address are archiving a historical record of a specific asset or system. Reality capture such as point cloud or texture mesh can serve as a 3D snapshot of the real world. Some vendors can even extract BIM data from these snapshots that can be used as either historical records or a starting point for future renovation or operations. 4 steps for implementing the digital twin are planning, surveying, modeling, and implementation. Let's look at these steps. To build a virtual representation of a site, you can compile information from various sources, such as LiDAR scans, interior laser scanning, subsurface utility locating, high-resolution drone imagery, and traditional surveys for ground control. The resulting 3D point cloud can be developed in the form of 3D building information in Autodesk Revit. Then the model can be converted to GIS 3D format in ArcGIS Pro. Hosting information on the cloud allows vendors to navigate and interact with the 3D model and its associated attributes in web browser, mobile app, and dashboard. This data can be utilized in future engineering design and construction at the office or in the field to help avoid delays and cost overruns. These dynamic simulations use available data-driven technology paired with the digital replica of physical assets to provide real-time and historical information for analysis and decision-making. The second problem that digital twin can solve is monitoring performance. One of the biggest benefits that GIS brings to the digital twin is that GIS can store, streams, and provide dynamic experiences to explore 3D assets as small as building or as large as a city, all in the context of the build and natural world around the assets. Let's deep dive more into how digital twin helps to solve operation performance monitoring. This demo shows the construction progress of the campus building in Redland using the drone flight data over time. This application helps compare the planned building model phases with the continuous development of the construction. It allows for user interaction with the orthomosaics and texture meshes over a period of time. Let's review the project when the initial grading process of the parking lot has been started. The next phase is completing the foundation layout. You can see the location of atrium area inside the building footprint and the marked locations for the supporting structural beams. We can review the next phase when the concrete for the base map and underground parking structure is completed. And also we see the steel structural elements of the building being put in place. The first floor is almost completed, and you can identify the bridge that is spanning the atrium. Now, the building roof has been completed, and the installation of solar panels begins. The last phase is when the construction process of the building is completed and all the landscaping features are in place. The building scene layer represents the original building design, and it can be explored and compared with these integrated meshes captured over time. I can filter different phases and view different levels of the building design. As you see in this demo, mesh and building scene layer integration allows us to have the reality capture of operation performance monitoring. The third problem that the digital twin can solve is predicting future performance. Some of the highest expectations around digital twins comes from using a high precision version of an asset to simulate, evaluate, and predict the future. In the AEC industry, aggregated beam information, Civil 3D, AutoCAD is used in virtual design and construction to play out planned construction and detect possible construction conflicts or safety issues. Digital twin helps you to predict your facility and the operation of your equipment. This can be done by monitoring the indoor environment with your IoT data from ArcGIS GeoEvent Server or ArcGIS Tracker to enable new spatial insights and optimize your business operations. Now, I will pass the ball to Hannah. Hannah will show us how to organize building information with floor-aware 2D and 3D indoor maps. Are you ready, Hannah?
Yep, ready to go. Let's dive in. So to continue our discussion around 3D GIS, let's dive deeper into leveraging CAD, BIM, and GIS data together for a more complete planning and design process. To address the challenges of being able to maintain a digital representation built from multiple sources and accessible across multiple disciplines, we can use ArcGIS Pro and ArcGIS Online to integrate data into a seamless 3D web scene for meaningful visualizations and an understanding of the environment at scale. The 2.8 release of ArcGIS Pro also yields more tools and a modified user interface, which have increased ease of use of the app, especially for daily data management. This first demo showcases best practices for working with CAD data in ArcGIS and the integration of CAD and GIS information to create realistic visualizations for facilities and building management professionals. With the ArcGIS indoor solution and a GIS-centric data model, we can integrate CAD with GIS to create a common operating picture that all stakeholders can use to make better, more informed decisions. Best practices for managing CAD data and bringing it into the GIS system involve first assigning your DWG, DGN, or DXF files the correct coordinate system. The tool called the Define Projection Geoprocessing tool can now be searched using the updated command search as of your ArcGIS Pro 2.8 update. ArcGIS Pro is a set of tools for georeferencing CAD data as well, and the same goes for georeferencing Civil 3D and BIM data types, the later types I will cover on in a moment. But before converting CAD data to ArcGIS format, select your CAD layers and watch for the geoprocessing menu to become active in ArcGIS Pro's main ribbon, the Manage CAD Layer toolbar, and then select the georeference option. After moving and scaling your CAD layers so that they align properly with the other GIS layers in the map, you must save the file along with its coordinate system to a new data set using the Save to Workspace button. A geoprocessing tool called Import Floor Plans to Indoors Geodatabase can be run to convert your CAD data to a GIS format designed by Esri for the built environment. Key inputs to this tool are the file geodatabase you want to use and an Excel mapping template file. This file is really important as it serves as a stepping stone from CAD to GIS formats, leveraging CAD layer annotation and using it to populate the GIS data model with, which will soon consist of a map of a building made of many feature classes. In addition to being able to map in 3D, this special GIS data model is also floor aware, which means that the end user or GIS analyst can navigate up and down or between floors in the building using the map's floor picker tool, which also runs on your mobile device. The GIS is able to differentiate between floors in the building based off of elevation and vertical order information, which is contained inside this data model. The building information will now exist as facilities, levels, units, or rooms and details layers. After CAD data is converted to GIS and the 2D map is converted to a 3D scene, 2D layers can be converted to 3D layers using the Layer 3D to Feature Class geoprocessing tool. The output will be a multi-patch type dataset. And lastly, before sharing this scene to my portal, this 3D facilities layer, which is highlighted now, can be customized further through the use of ArcGIS Pro's Edit Session and a multi-patch texture tool. Rule packages provided by Esri and textures obtained from image files can be applied to this multi-patch layer inside ArcGIS Pro to add that extra touch and really customize the look and feel of your 3D scenes. Once all needed map layers are compiled and layer symbology is defined, the 3D scene can be shared to your portal using ArcGIS Pro's share tools. To provide realistic 3D scenes of the built environment, web applications can be created from simple web maps and scenes or using ArcGIS Indoor's configurable web applications. This out-of-the-box solution and tools provides an easy and efficient way to piece together your applications using web maps and web scenes. Like many of the Esri solutions, no coding is required here. This final web application has the ability to toggle between 2D maps and 3D scenes at the click of a button and features search capabilities so that layers can be searched and queried by the end user as they wish. These layers consist of any asset you would like to track inside the buildings, the building floors or room themselves, or even staff working in and around the buildings. And as a final note with this first demo, ArcGIS Indoors isn't needed for every 3D web app out there. As an alternative to the Import Floor Plans to Indoors tool, the CAD to Geodatabase tool can be run inside ArcGIS Pro to convert your CAD layers to a 2D or 3D GIS format. So adding a realistic 3D context to your building planning and design information can add further insight and help with making business decisions, as we know, as we've been discussing. With updates with 3D tool sets across the ArcGIS system, now we can visualize and interrogate design and construction information contained within Civil 3D data and view these objects as they were intended to be drawn in reality, rather than as simple top-down 2D CAD drawings. Through uniting Civil 3D and GIS realms, we can incorporate building project design information into a realistic and informative 3D view to easily access the data we need to carry out important design coordination and impact changes. Civil 3D drawings are managed and manipulated inside ArcGIS Pro in a very similar way to a CAD file. Recent development of the application allows ArcGIS Pro to render the Civil 3D data by simply dragging and dropping it into the map from anywhere on your computer, as you wish. Perhaps the most important step to georeferencing is to choose a layer inside the Civil 3D groups to georeference with. It is a best practice I have found to use either a polyline or a polygon layer inside the Civil file. And as a tip, creating bookmarks in your project will help you navigate your maps with ease when you georeference. Ensure you use the Define Projection tool as well if your Civil 3D data does not already come with a coordinate system previously defined. To convert your data, we will use the CAD to Geodatabase tool. This tool will take Civil 3D drawing components and insert them into an empty file geodatabase. Each layer in this file geodatabase will have attributes that are populated with the drawing layers information. Once the tool is run, you will see that your destination file geodatabase will now be populated with feature classes corresponding to the layers inside the Civil 3D file. These will consist of point, annotation, multi-patch, polygon, and surface points feature classes. These layers can now be manipulated however you like. And as an add-on, you can enable underground navigation in your 3D scenes at any time by selecting Ground in your Contents menu and using the Appearance selection of ArcGIS Pro's ribbon. So to prepare my data next for the web scene I'm about to create, I'll make one more change to these building polygons before converting them to multi-patch features. I want to extrude these homes and add some height to them. To extrude the polygons, I'll select the polygon layer's elevation field, which I have set previously to a value of 8 meters. To add, a multi-patch layer stores a collection of patches representing a 3D object as a single row in a database. Because this is extremely valuable to our realistic 3D scene, as a multi-patch feature has the ability to store texture, color, and transparency information. And what we will see now is a scene layer package representing our 3D buildings, which for demo purposes was set up ahead of time in CityEngine and shared to ArcGIS Online. To add context to the subdivision grading plan, I gathered some data from the city of Kamloops to group them into a utilities group. Now, we don't want to lock all of this information away in ArcGIS Pro. We want to share and collaborate this information so that we can assist others with important design and engineering decisions. Just like the scene layer package here that I have previously added to ArcGIS Online from CityEngine, we can visualize data and combine it from Civil 3D format along with other GIS data in a 3D web scene. Most of the legwork is done ahead of time to prepare the data for the scene, but this user-friendly nature of the ArcGIS Online 3D web scene enables you to quickly add content and combine and overlay information at ArcGIS Online. And in addition to the wonderful quality of the textured buildings in our subdivision grading plan scene we see here, we can really leverage our data obtained from Civil 3D files, just like any other GIS layer using ArcGIS. We can use ArcGIS Pro to configure something called a layer pop-up for layers so that our end users can interact and interrogate this civil plan information right in the web browser. And along with Civil 3D and CAD data types, last but not least, BIM data, central to many architectural, engineering, and construction workflows, can be brought directly into ArcGIS and converted to a GIS format using ArcGIS Pro. This data type is especially advantageous because design information contained within Revit can be incorporated into the GIS, allowing our users and our colleagues to view and access and query this information right in the GIS. This data can be mapped in 3D format and includes valuable architectural, structural, mechanical, and electrical information for your structures. ArcGIS Pro's georeferencing toolbar is used with Revit data in a very similar way as when georeferencing a Civil 3D or a CAD file in ArcGIS Pro. Georeferencing is required for your Revit data before it can be mapped in a 3D scene in ArcGIS at any time. These 3D scenes can reside either in ArcGIS Pro or in any web client you wish to consume your data with. In the case of our demo today, I've been using a little bit of ArcGIS Enterprise, but focus in ArcGIS Online. You can georeference a Revit file in a 2D map or in a 3D scene. This data must be georeferenced, however, before it can be worked and analyzed and mapped further. If you're working in a local scene with a geographic coordinate system, you must convert it to a global scene before publishing. And once ArcGIS Pro has been licensed to use the ArcGIS Indoors Toolbox and georeferencing has been complete, the import BIM to indoor dataset geoprocessing tool can be run to convert your Revit file to a file geodatabase. As a best practice, you can also convert your entire map and make the process quicker and more efficient and all the data within it to a local or global scene using the view tools inside the ArcGIS Pro main ribbon. In addition to converting the map to a 3D scene, you must also convert the 2D map layers to 3D map layers. And this is done using a tool called the Layer 3D to Feature Class Geoprocessing tool. These tools can be accessed via the Geoprocessing menu or Tool History pane, but as of Pro version 2.8, the command search can be used at any time to search any tool within the ArcGIS Pro toolkit. With recent updates to the ArcGIS system, which include ArcGIS Pro and ArcGIS Online to focus on, we can now create realistic 3D maps and visualizations from BIM Revit. There are a handful of useful methods that ArcGIS offers for adding scene layers to your portal. One of the most effective ways and quickest ways is using the Create 3D Object Scene Layer tool. The 3D Scene Layer package, once it has been created, you can add it to your portal site manually using an add-in button when in your content page as seen here. Once your 3D Object Scene Layer package has been added to the portal, it can now be used to create any web scene or web app you wish to build. Here I've configured a simple web scene to show you how quick and easy it is to combine the data that has been sourced from Revit into a 3D scene in your portal. I would like to add my built structure's floor plan information as a scene layer as seen here. This data has been shared to my portal site ahead of time for demo purposes. And last but not least, and for a final touch, I've created a configurable web application that I really like. It's called the Comparison application. This app has been created for demo's sake so that we can really showcase BIM information right alongside GIS information in the same view. Note here that 3D layers obtained from Revit files can be visualized and queried, interrogated in the same exact view as the GIS data, providing that they've been converted to a file geodatabase or shapefile format ahead of time and have coordinate system information that is compatible with your web scene. It's highly recommended that all GIS enthusiasts follow the Esri documentation for how to create 3D scenes using ArcGIS Pro and analyze this data and scene when publishing. All right, thank you. Over to you, Cynthia.
Thank you so much, Hannah. Great demo. To extract your data for your digital twins, you can take advantage of ArcGIS Pro and 3D Basemap solution. The 3D Basemap solution helps your organization leverage LiDAR and point cloud to generate 3D objects, such as ground elevation layers, buildings, trees, and bridges. Much new enhancement has been added to this solution, such as developing distribution and transmission lines in 3D and turning your existing 2D underground utility features into 3D features. Once you have 3D basemap layers, you can publish them in ArcGIS Online or ArcGIS Enterprise, so the member of your organization and the general public can interact with them. You can integrate this solution with other applications, such as ArcGIS Airband, or use it in assessment development impact and flood impact analysis solutions. Let me show you this solution. This demo will review the new enhancement in the newly released version of the 3D Basemap solution. 3D Basemap is a configuration of ArcGIS Pro that provides tools and tasks to extract elevation surface, buildings, 3D floors, bridges, and trees from LiDAR or point cloud. It also generates a 3D power line and 3D underground pipe from the 2D feature class. You can access the 3D Basemap solution from ArcGIS Solution App Launcher. You must have a creator or GIS professional user type to deploy the solution in your ArcGIS Online or ArcGIS Enterprise 10.9. Then you can download the 3D Basemap project package on your desktop. You need ArcGIS Pro Advanced with 3D Analyst and the Special Analyst extensions to work with the provided tasks. Let's start by extracting the elevation surface from the city of Naperville LiDAR data. To extract the elevation surface, you should make sure that your LAS files have a ground classification. This task helps generate a digital elevation model, digital surface model, and normalized raster. Suppose you receive the LAS file that doesn't have ground classification. You can use Classify LAS Ground tool to add the ground classification to the LiDAR. Now, let's deep dive into the buildings task. If your LAS file has a building class, you can extract building footprints from it. But if it doesn't have any building classification, you need a projected building footprint polygon to assign class code 6 to the LAS points that intersect with your building polygon. The Create Building task will generate a 3D building polygon with accurate roof form and a multi-patch feature class from the building footprint. To apply texture to these buildings, you can download the Texture LOD2 building rule package from ArcGIS Online and use it as input parameter in Add Texture to Existing Buildings too. Another new enhancement allows us to split the building into floors based on space use type or floor parameters. To use the space use type, you need a spreadsheet with attributes about building type, space use type, the number of floors, the height of the ground floor, and the height for upper floors for each building type. This spreadsheet will be added as an input parameter in the split building into floors tool. This tool uses the building multi-patch layer to generate the floors. Here you go. Also, we can use Extrude by Attribute task to create floor volumes using the height of the floors. Now, let's move on to the next task of creating bridges. If the bridge surface has a class code in the LiDAR, extracting the bridge surfaces as 3D polygons is possible. The Extract Bridge Surface from the LiDAR tool generate only polygon feature class. However, you can apply the bridge procedural rule provided by Esri to create the 3D bridge model. If you are interested in publishing this layer to ArcGIS Online, you can use Create 3D Bridges to convert 3D polygon to a multi-patch feature class. Now, let's move on to the next task of extracting trees from LiDAR. If your LiDAR doesn't have a vegetation class code, you can use a deep learning model provided by Esri to add vegetation class code to the LAS file. To work with the deep learning tools in ArcGIS Pro, you need to install supported deep learning framework packages in your machine. You can access deep learning libraries and installers from GitHub. Classify trees in LiDAR using the deep learning tool. Only accepts the folder that contains LAS files projected with the unit in meter as a parameter. The output of this tool is a new LAS dataset that resides in an empty folder, and it has a vegetation class code. Also, you can use extract tree points using surface analysis to create 3 points from the LAS file. This tool requires vegetation class code, building footprint, and digital elevation model to generate a point feature class. Then you can use add preset layer symbology to display these points as realistic looking 3D trees. These 3D points are great, but you can't use them for any analytical purposes like a shadow analysis or visibility analysis. Create an analytical trees tool helps you to convert this 3D layer to a multi-patch feature class with thematic symbology. Create colorized trees uses aerial imagery to colorize LiDAR points. A new task has been added to this solution that helps us to generate transmission lines and distribution lines from point and line feature classes. Let's review the transmission line tool. This tool accepts the point feature class as an input. In the case of a point feature class, line and tower attributes must be present in its attribute table. The line attribute should describe which line the points belong to, and the tower attribute should define the tower order per line. This tool allows us to set voltage and tower configurations such as tower height and structure type. Another new enhancement is generating 3D subsurface pipe features from 2D feature classes. You need the polyline feature class to represent sewer mains and lateral, and point features to represent pipe junctions, for example, manhole. These tasks look for elevation values for locating your pipe underground. They help you to identify the missing elevation attributes and interpolate the missing Z values. You can also reevaluate the interpolated result and have the manual correction on the elevation. Then you can create a 3D buffer around your main to produce cylindrical features. For manholes, we follow the same steps. We create an interpolated layer to identify those manholes that have missing elevation values. Then we make an update to incorrect elevation and rerun the interpolate Z value to make an update to the original data. Also, we can symbolize the original manhole with a city engine rule package provided by Esri. Also, you can apply the invert height to your symbology. The Create 3D Manhole tool allows you to create a multi-patch feature. We can publish this 3D base map to ArcGIS Online or ArcGIS Enterprise to be shared with other applications like ArcGIS Airband to visualize and analyze your planning scenario. I can't wait to see how you use this solution in your organization. The reality capture mesh can serve as a 3D snapshot of the real world. Now, would you please, Lee, elaborate more about the integrated mesh and tell us what we should learn about this solution?
Absolutely. So I thought I'd take the opportunity to share a really busy slide, and I'm going to work from the top down and going from left to right. Now, Esri offers at the very top here a variety of products that will allow you to create 3D content. Starting with Drone to Map, which is built for disconnected environments on desktop computers. You can process data to create 3D meshes and photogrammetric point clouds. Next is SiteScan. SiteScan allows you to do very similar work, but also allows you to plan your survey and in a cloud-based environment. So it's very similar to Drone to Map, but instead this is a cloud-based software product. Next is Sure, or a product that was originally built by a company called N-Frames. Recently, Esri acquired N-Frames and adopted the product Sure software. This is a product built for massive data production on desktop or distributed processing systems. So the amount of data that you would process in Sure would typically be at the provincial scale or even at an entire nation scale. Now, all of these products that I've mentioned can create integrated mesh, photogrammetric point clouds, surface models, and things like that. Finally, another production product is ArcGIS Pro, which I'm sure most of you have heard about. This product, it really excels in feature extraction from LiDAR, building elevation data sets, so DEMs, DTMs, DSMs, or normalized data sets. And then it also allows you to do LiDAR classification and 3D base map management. All of these products combined, they can publish to ArcGIS Online or Enterprise, and also into ArcGIS Pro, which can act as your management system. Once it's in the ArcGIS Online and Enterprise, you can build applications that consume your 3D content, and a lot of these web applications that you push this 3D content into, whether or not it's integrated mesh, point cloud, and we're talking billions of points in your point cloud data, 3D buildings, can all be consumed on the web and even down to a mobile device streaming through the internet. Thank you.
Thank you, Lee. Let's move on to the next demo and look at the value that integrated mesh from Sure for ArcGIS can provide to our digital twin workflows. We wanted to show you how combining integrated mesh with 3D and 2D data helps simulate, evaluate, and predict the future. In this demo, I wanted to show you how reality capture applies to our urban area. Let's look at the city of Frankfurt in Germany. With new processing technology, we can build a 3D mesh of Frankfurt using Sure for ArcGIS. This mesh was created from over 800 2D aerial images collected by drones over the entire city. The data was processed using a site scan. And as you see, it produced a high-resolution 3D mesh. Thanks to the latest enhancement of Scene Viewer in ArcGIS Online, we can quickly create elevation profile charts to explore the elevation and view statistics such as elevation gain or slope. Now, slicing the mesh reveals occluded content in a scene and reveals a more underlying reality and detailed information about the bridge. Flood layers and impacted building layers can be overlaid on this mesh to illustrate the flood's impact on the buildings. The pop-up information shows the infrastructure damage cost, the potential loss, and the flood's depth in that area. Finally, we can drop a point cloud classified based on its RGB values to provide the wealth of information beyond the mesh. Let's enhance this 3D scene with more exploratory analysis by sharing it into 3D Viewer app in ArcGIS Online. To modify the application, I switched the app to the full setup option. Now we can configure an inset map to be stacked to the scene. We can add daylight animation and line of sight analysis tools. We can modify the elevation profile with metric unit. We can add a slice tool and embed creating snapshots and exploring the scene with address information. Now we publish and launch the application. In this way, we can analyze shadows' impact on surrounding buildings and conduct visibility assessment. This reality capture helps public safety and public work to perform feasibility studies and know where to evacuate people before the flood occurs. Nearmap is a partner of Israel Canada who has provided texture mesh, point cloud, DEM, DSM, and high-resolution aerial imagery in Canada. For the Canadian user, they can make the mesh available as an offline delivery in SLPK format or online with an export capability to export the area you want. The point cloud is in the form of an LAS file with 3 bands and 44 points per square meter. Nearmap captures aerial imagery proactively with a methodical capture plan in Canada, so it's available immediately. This application shows the Nearmap's Canadian coverage. I attached the URL of this application to the slide so you can contact them at nearmap.com. We can see Halifax, Moncton, Quebec, Montreal, Saskatoon, Edmonton, and Calgary, and many other cities in East and West. We can see the city of Winnipeg and Kelowna and Vancouver as well. Let me show you how 3D Mesh retrieved from Nearmap can modernize how organizations visualize data and analyze information. In this demo, I wanted to show you how planners use the integrated mesh to create a digital twin of the built environment and simulate the entire city to predict future development plans. Toronto has experienced a housing squeeze where many residents are stressed about finding and keeping a place to live. Let's evaluate the development plan of an affordable housing for Toronto's future residents. Let's dive into the Newton Brook East and interact with the development site using integrated mesh provided by Nearmap. Mesh is stored as a scene layer package and can be added to your scene from the catalog pane. Here, we can quickly flatten the integrated mesh at the footprint of the new scenario. To modify the integrated mesh, first, I create a new modification. And then I apply the replacement operation to flatten the footprint and make it ready to bring the proposal plan to the site. I draw the footprint polygon of the proposed plan to define a new scenario. After I modify the mesh, I will save the edits. Now the site is ready to add the proposed plan. These buildings are 3D object scene layer created from a multi-patch feature layer. They are designed in ArcGIS Urban and ArcGIS CityNG. This proposed plan can serve a 6,000 population and it provides 20,000 parking spots for 3,000 households. ArcGIS Pro allows us to simulate three-dimensional models of CO2 emissions caused by these high-rise buildings. One way to visualize the CO2 emissions prediction is to create a voxel layer using empirical Bayesian Kringing 3D and GA layer 3D to NetCDF tools. The empirical Bayesian Kringing 3D interpolates the CO2 measurements into a continuous model that predicts CO2 emission everywhere between the measure points. The GA Layers 3D to NetCDF tool export the CO2 interpolated model to a voxel layer. Let me take you on a quick tour of calculating this voxel. To start, we need an accurate measurement of CO2 emissions produced by each building. ArcGIS Airband helps predict the CO2 emission for the entire proposed plan. We see the empirical Bayesian Kriging 3D geoprocessing tool to interpolate the CO2 measurements. The 3D geostatistical layer automatically enables a range slider. Depend on the household population and height of each building, the amount of CO2 emission will be varied. The GA Layer 3D to NetCDF tool export this CO2 interpolated model to voxel. One way to reduce carbon emissions is to mitigate fossil fuel electricity production by using renewable energy. The Development Impact Analysis solution delivers a set of tasks that help us calculate yearly solar radiation raster for the proposed development. This solution allows us to calculate the total solar radiation for each building and visualize solar radiation raster on buildings. As you see in this demo, ArcGIS Pro helps to simulate the next digital twin of tomorrow. Now it's time to talk about what's new at Esri with 3D. Turn it back to you, Lee.
Thank you. So there's a lot to talk about with what's new at Esri with 3D. So I've made a selection of just a subset of those items. And at the end, I'm going to show you a complete list, not a complete list, but a more complete list than what I'm going to highlight in this talk. I've broken out the sections into 5 categories: visualization, 3D analysis, 3D content creation, 3D scenes, and that's going to be focused on what we can do in the web, and then gaming engines. Starting off with visualization, how things look is really important at Esri. So when you want to create a map, we are really concerned about how it looks, and we want to make sure that we're giving you the best tools. For 3D, it's no exception. We've spent a lot of time this year building out our capabilities for visualization across the platform. Things like our voxel rendering, shading and ambient occlusion. We're focusing a lot of time on physical-based rendering. That includes objects with materials, reflectivity, water bodies, the reflection of buildings off of water, also 3D symbols and animation and temporal visualization, all within a 3D platform. For 3D analysts, we've got 2 thoughts on this. So there is an interactive and a derived. With interactive analysis, this is something that we've been building over the last couple of years, but each year we're coming out with new functionality. Interactive analysis is analysis that occurs on the screen in the runtime at the moment that you're running the analysis. So no output is created. We have tools for line of sight, viewshed, view domes. We're doing slices, cut and fill, and other types of visual analysis. So exploratory visual analysis can happen on the desktop application like ArcGIS Pro, or even in the web. For derived analytics, we spent a lot of time on voxels and visualizing huge volumes of multi-dimensional content. On the screen, you're seeing the geology across all of the Netherlands at a half-meter vertical resolution. And then we're even allowing you to create voxels through a high-end 3D empirical Bayesian Kriging method, which allows you to create your own voxel representation of anything that could be subsurface or environmental or atmospheric layers. To continue with the 3D analysis, we spent a lot of time on LiDAR classification. This year, we've spent a lot of time on coming up with deep learning models with LiDAR. So we're trying to create repeatable workflows and publish those to the community that you can create your own, that allows you to create a high-end classification method. Currently, the 3D base map solution that Siddhi mentioned earlier is using a deep learning model for classifying trees, and this classification method works really well. We've produced enough training data out of one of our R&D offices for you to build or to deploy the model and run it on your own and get a fairly accurate representation of classification. Other things that we're doing with deep learning is training it to identify power lines, and if anyone is familiar with LiDAR, that is a really challenging task because the power line points really make up only 0.1% of a LiDAR survey. So it's a really challenging thing. But once you have that classified correctly, you can start to represent those power lines with the 3D base map utility line toolset. Other things that we're doing is classification by proximity, not just 2D proximity, but 3D proximity. And then another thing that customers have been asking for a long time now is a LiDAR profile view. And this just lets you view your LiDAR as a cross section, which is something that a lot of people that do classification of LiDAR, a lot of what they've been asking for a long time. So this is exciting to get this finally out. Next up is content creation, editing, and data management. So this year, for the UC release, we're going to be supporting a web-based 3D editing experience. This is going to be very similar to the 2D web-based editing, and the same team is building the same workflow. So we're trying to keep synergy between the two experiences, so you don't have to learn two different methods of editing. We're also improving our symbology with enhanced smart mapping. And then we're also going to be supporting inline snapping. So inline snapping will allow you to do editing in 3D on the web and snap it to built environments. So in the case that I have here on the screen is we're digitizing a line to follow a staircase, or you could even have it follow the natural environment, so a digital elevation model that's in your scene. So if you were digitizing the perimeter of a forest fire, it would follow that relief. This isn't just a graphic editing, this is actually editing features inside of a geodatabase and actually getting pushed back to your backend database. Finally is mesh modification. So it's great to be able to create all of these meshes, but you may want to flatten the mesh in certain areas where a building is going to be replaced to view a new proposed property. So in this case, we're allowing you to modify or make modifications to that mesh and publish the data with that modification. By doing so, you're going to be able to swap out that area or that building and bring in a new model just to view to see how it looks in that scenario. Now with web scenes, content creation and editing and data management continues. So we're going to be enabling you to configure pop-ups inside of our web scenes, just like you could in the 2D map. You're going to be able to create 2D billboarded symbols. That will be a symbol that'll stand upright, it'll be flat and rotate as your camera moves around it. You're going to have multi-field filtering. This is great because before you could only filter based on one field, but now you're going to be able to narrow down your data based on multiple fields. And then we're also going to be improving our I3S specification. And if anyone's not familiar with I3S, that is our standard for how we publish 3D content onto the web. Now on here, I say the newest release is 2 times as fast, but in some cases we're seeing it's 4 times faster than previous years. This is something that we're continuously improving, so just keep an eye on that. Now, if you have an older 3D scene service, that's fine because we are actually creating an update scene layer package tool that will update your scene layer package from past releases to the newest 1.7 version, which will give you that performance bump. The other thing that we're going to be doing, and we're really excited about this, is the ability to clip and project a scene layer package. So you'll be able to cut out a scene layer package to a smaller extent and then reproject it to another coordinate system that suits your needs. This is really exciting because before we were not able to do that, and you would actually have to get all of the source data to be able to do this type of task. Now, game engines. We've spent some time this year. Our runtime team has developed two, I like to call them bridges, but they're essentially bridges into game engines, Unity and Unreal. What you're going to be looking for is ArcGIS Maps SDK for game engines. This is two separate code bases that allow you to bring geographic content from ArcGIS into Unity and Unreal, which allows you to start creating really high quality visualizations, which will support environmental conditions and enhance and even better material rendering, and will allow you to push it to some sort of a VR or AR, XR experience. So we're really excited about this. We just released our beta 2. I highly encourage you to get into that beta and start playing around with the gaming engines. Now, finally, like I said, there are so many things happening at Esri around 3D. I just can't list it all. So what I wanted to do is show you a recent midterm and long-term goal on all of our tasks. And this isn't even all of them or all of the enhancements that we're going to be putting into our product. This is highly subject to change based on our development cycle and how things go. But I just wanted to share that with you. So please take a screenshot of this, take notes of it. Feel free to ask me any questions on any of these points, but I just wanted to share this information with you. Thank you. I'm really enjoying participating in this. So if you have any questions, please feel free to reach out to me.
Okay, let's take a couple of questions at this time. Lee, would you please address a couple of them?
Sure. Do you have anything in here that you see would I can let me see. Let's see. So someone was asking about the support of multi-patches going into Civil 3D. Right now, that's not something that they are currently supporting, and we can't get those in there. It would be, it is on them to start supporting. So that is something that we can't do today, unfortunately. But what else do we have here? Someone asked a question about georeferencing their Revit models. When you bring in a .rvt file into ArcGIS Pro, you'll see on your ribbon at the top of your screen that there will be a new option called, I think it's referred to as georeference, and that's something that you'll be able to follow through. And it's very similar to any other georeferencing method. You start creating and specify where it goes. One thing that I need to mention on that is it's really important that when you're georeferencing a Revit model, make sure that the scene coordinate system is in the desired coordinate system that you want that Revit model to be in. It's really important. Otherwise, it'll take on the coordinate system of whatever you have, and it could be Web Mercator or whatever.
Okay.
Yeah.
So we move on to the next slide. We have an upcoming training class related to working with 3D in ArcGIS Pro. This course teaches the fundamental concept of 3D GIS. You will learn how to visualize, edit, model, and analyze data in a 3D context. Also, we would like to invite everyone to register for the upcoming Esri user conference occurring on July 12 to 15. We included the links for the blog post and help document that we use for this webinar for your sake. You can find a link for optimizing your ArcGIS Pro for working with 3D content. It takes you through the steps for troubleshooting performance issues in ArcGIS Pro. Feel free to contact Lee, Hannah, and me with any questions about the 3D solutions. Thank you for taking time out of your day and participating in today's webinar. We will email you a recording of the webinar shortly, as well as a PDF of the slides. We would also like to get your thoughts on the presentation. So please fill out the surveys that comes up when you exit the webinar. We will now stop the recording and take questions again at this point.